You've probably seen it, right? You glance at the weather report and it's like you're trying to read some ancient secret language. You've got these swirling lines, these giant H's and L's. What on earth do they actually mean? Well, over the next few minutes, we are going to crack that code together. I mean, it really does look like a map of mysteries, doesn't it? But here's the thing. Every single symbol, every line on that screen is telling a story. A really important story about that huge ocean of air that's constantly moving right above our heads. So let's kick things off with a big question. Yeah, you see this stuff on the news every single night, and it looks so complex, right? Like some secret code that only meteorologists are in on. But what if I told you that by the end of this little explainer, you'll be able to look at this and know exactly what's going on? The whole story of whether you're going to need a jacket or an umbrella, it's written right there on that map. All right, so to start cracking this code, we need the first key. And that key is understanding one of the most basic forces on our entire planet: wind. I know, it seems simple, but what actually makes it blow? Okay, let's just get a super clear definition on the table first. Wind? It's just air on the move. That's it. Specifically, air moving horizontally across the Earth's surface. But, and this is the important part, this movement isn't random at all. It's not just chaos. It's driven by a really simple but really powerful rule. Okay, here it is. This is the single most important rule to remember. Air always flows from an area of high pressure to an area of low pressure. Always. You know, think of it like a really crowded room. What do people do? They naturally move from the packed center out toward the emptier edges where there's more space, right? Well, air does the exact same thing. Always from H to L. That is the golden rule. Okay, but hang on a second. If air just moves in a straight line from high to low pressure, then why do all the weather maps have these beautiful, swirling patterns? Why isn't it just a straight shot from point A to point B? Well, it turns out our planet has a little secret. A cosmic spin, if you will. So, imagine you have a balloon, and it's not moving at all, it's just sitting there. Now, if you take a little bit of ink and let it run down the side, what happens? It makes a perfectly straight line from top to bottom. Super simple, right? Totally predictable. Yep, on a surface that isn't spinning, you get a simple, straight path. This is our baseline, our starting point. Now, let's add a little spin and see what happens. Okay, so what happens if we do the exact same thing, but this time the balloon is spinning? You might think you'd still get a straight line, but nope. Watch what happens. The line actually curves. Would you look at that? The line totally deflects. It curves because the surface underneath it is moving. The ink is trying to go in a straight line, but the spinning balloon is basically pulling the ground out from under it. And this is exactly what's happening on a planetary scale on our spinning Earth. And this whole bending phenomenon, it has a name. It's called the Coriolis effect. It is the Earth's rotation and the Earth's rotation alone that gives the wind its curve. This is the secret ingredient, the magic twist that transforms a simple straight line of wind into those amazing swirling patterns we see on every single weather map. All right, so we've got our two main keys. Number one, air flows from high to low pressure. Number two, the Earth's spin gives everything a little twist. So now let's put them together and finally unlock what those big H's and L's on the map actually mean for your day. Okay, this is where it all clicks into place. In a high-pressure system, that's our H, air is sinking down from above and spiraling outward in a clockwise direction. A super easy way to remember this, just think H for happy weather. Now, in a low-pressure system, our L, air is rising up from the ground and spiraling inward, counterclockwise. And for that one, you guessed it, think L for lousy weather. Let's actually see what this looks like in the real world. So, when you see a big H sitting on the weather map, it means air is gently sinking down. As that air sinks, it actually warms up and dries out, and that makes it really, really hard for clouds to form. So what's the result? Clear, sunny skies. See? High pressure equals happy weather. And you guessed it, when you see an L, it's the exact opposite. That means air is rising up from the ground. As it rises, it cools down, and all the moisture in that air starts to condense and form clouds. This is literally the engine for all kinds of active weather. We're talking everything from a simple cloudy day, to rain, to even massive storms. Low pressure, lousy weather. It really is that straightforward. So there you have it. You can now read the basic story of a weather map. You know what the H's and L's mean. But have you ever stopped to think about where all this data comes from in the first place? I mean, who or what is watching the weather 24/7? Well, let's meet the global team of weather watchers. First up, meet the radiosonde. Twice a day, every single day, from hundreds of places all over the globe, these little packs of instruments get sent up on weather balloons. They soar way up high into the atmosphere, and they give us a vertical slice, a snapshot of the temperature, pressure, and humidity up there. It's kind of like giving the sky a checkup. And look, since about 2/3 of our planet is covered by water, and so much of our weather is born out there, we desperately need eyes on the ocean. And that is where these weather buoys come in. These things are basically floating sentinels, just bobbing out there in the huge, vast oceans, constantly beaming back absolutely crucial data from the sea surface. And then, of course, we have the satellites. Orbiting way up high above us all, they give us that incredible bird's eye view. This is what lets us see the big picture, the grand structure and movement of entire weather systems as they literally march across continents and oceans. So all of this data from the balloons, the buoys, the satellites, it all gets fed into these massive supercomputers that run the models that create the forecasts we rely on every single day. And, in today's world, being able to understand those forecasts and what they're really telling us is more important than it's ever been. Okay, here is a really crucial point to remember. A weather forecast is a probability, not a promise. The atmosphere is just an incredibly complex, chaotic system. And that's exactly why a forecast for tomorrow is way more reliable than a forecast for next Tuesday. Those tiny little uncertainties, they just grow and grow and grow over time. I mean, just think about it for a second. These forecasts do everything. They give you a heads up to grab your umbrella on the way out the door. They help farmers figure out the perfect time to plant their crops. They help pilots navigate safely through the skies. They're this critical but often invisible part of our modern world. From the most beautiful, serene, sunny days to the sheer, awesome power of a thunderstorm, these forecasts are what help us navigate the atmosphere's constantly changing moods. They really are our guide to the sky. So I'm going to leave you with this one final thought. In a world where our climate is definitely changing and extreme weather seems to be on the rise, being able to understand the forecast, well, it's not just a neat party trick anymore, is it? It's really becoming an essential skill. And now, the next time you see one of those weather maps, you won't see a mystery. You'll know exactly what story it's trying to tell you.